Today we're going to talk about whether or not a function is linear in different representations. So first we're going to look at a graph. So a linear function is a straight line. So if I'm looking at my graphs here, the one that's going to be my linear function is this first one because it has a straight line. A non-linear function is a function that's not a straight line. So if it's not straight line, it's going to be, here it's curved, non-linear. Let's look at a table. So for a table, a linear function has a constant rate of change. So what that means is that you are going to add or subtract the same value between the x values and the y values. Well, what does that mean? So if I look at my x values here, how do I get from 1 to 2? I'm adding 1. From 2 to 3, I'm adding 1. From 3 to 4, I'm adding 1. It's the same all across the top for my x values. For my y values, to get from -1 to 2, I'm adding 3. 2 to 5, I'm adding 3. 5 to 8, I'm adding 3. Because the top is constant, adding the same thing. The bottom is constant, it's adding the same thing. That's going to be a linear function. But if I look down here, a nonlinear function does not have a constant rate of change. So if I look here, I see my x is -1 to 0, okay, that's +1, 0 to 1, that's +1 again, 1 to 2 is +1 again. So right now it looks like it could be linear, but you need to test the y's. From 0 to -1, it's -1. From -1 to 0, it's +1. From 0 to 3, it's +3. These are not all the same, so this is non-linear. Now let's look at your equations. So in an equation form, a linear function can be written as y equals mx plus b. You should be familiar with this from middle school. The x value does not have an exponent if it's linear. There are some special case lines that are x equals a number and y equals a number. X equals a number are the graphs that go up and down. Y equals a number are the graphs that go left to right. So if I look here, I see this y equals 3 minus 2x. My x does not have an exponent. This is linear. But let's look at some things that we're going to make an equation not linear. So a nonlinear function can have an x value with an exponent, or an x in the denominator, which is the bottom of a fraction, or an x inside of a radical, which this is a radical with an x inside, or any variable. So here I'm looking at, I've got x cubed, that has an exponent, so this is non-linear. So we're going to look at some more examples, looking at different representations to decide if they're linear or nonlinear, and we're going to write a reason. So let's look at number 1, y equals 2. This is linear, and the reason why, it's one of these special case lines. Number 2, I'm looking here at y equals square root of x, that's a radical, plus 5. So because of this, it is nonlinear because x is in a radical. Number 3, I've got x equals 5. This is one of those special case lines. It would be graphed like this. So this is linear because it is a special case line. Number 4, I don't see x with an exponent or in the denominator or inside of a radical, but I do want to rewrite it into y equals mx plus b form. That is one of the things it says. It can be written as y equals mx plus b form. So to get y by itself, I subtract 2. So y equals 3x plus 2. This is linear because it's in y equals mx plus b form. All right, let's look at a couple of tables. So when it's in table format, I'm checking to see that I have a constant rate of change. So my constant rate of change is looking at the change in the x values and the change in the y values. So for this one, I'm going to look from 5 to 7 is +2. 7 to 9 plus 2, 9 to 11 plus 2. Here, 9 to negative 3, that's plus 6. Negative 3 to negative 1, that is plus 2. Negative 1 to 3, that's plus 4. Okay, these are all the same. These are not. So this is nonlinear because there's not a constant rate of change. Let's look at our next table. Again, x values first, that's plus 1, plus 1, plus 1. Let's check our y values. 5 to 10 is plus 5, 10 to 15 plus 5, 15 to 20 plus 5. All the same values across the top, all the same values across the bottom for the differences. So this is linear because it has a constant rate of, let me scoot this over, constant rate of change. Okay, we're gonna look at a few graphs. This is probably the easiest way to recognize a linear function. If it's a straight line, it's a linear function. If it's not a linear function. So here I've got a curved graph. This is not linear because it's not straight. Number 8, I also see this curving graph. So this again is nonlinear because it is not straight. Last one, number 9. This is a straight line. So this is linear because it is straight. So this is how you determine if a function is linear or not linear.